Hello everyone. So today let's solve the problem batteries, right? So this was asked in the code forces around 1056 for the division 2. Yep. So you can just go through the question. It's easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Yeah. So just give me a second, 1 second here. So yeah, let's see what the question states here. Right. So there are n batteries here, right? So there are n batteries. So constraint is n is greater than or equal to 2 and less than or equal to 40, right? So just remember n is greater than or equal to 2 and less than or equal to 40, right? So there are n batteries. So we can test any pair u comma v. So this problem is related to the graph matching actually. So we can test any pair u comma v and receive 1. We can test any pair u comma v and receive 1. If both work, then flashlight is on. If both work, then the flashlight is on, or 0 otherwise, or off actually, or 0 otherwise, yeah, or 0 otherwise. We have to find any working pair using at most this one, n into 2 to the power of m queries, yeah, n into 2 to the power of x queries, right? So interaction in the simple terms here, a is greater than or equal to 2. Just remember one thing, a is greater than or equal to 2. That is guaranteed, right? A is greater than or equal to 2 is guaranteed. By querying the pairs until the interactor returns 1, until the interactor, this one, returns 1. Yeah, so this is the question. Let me read the question out loud. Just listen to this carefully. This one, what do we call? We have been given n batteries, right? So there are n batteries. N is greater than or equal to 2 and less than or equal to 40. Just remember this. This is important. We can test any pair, nothing but u comma v, and receive 1 if both work. Flashlight is on, right? Or 0 otherwise, or 0 otherwise, right? Nothing but off actually, flashlight off. So we have to find any working pair using at most this one, n into 10, 2 to the power of n queries, right? For the interaction. Then here a greater than or equal to 2 is guaranteed, and also by querying pairs until the interactor returns 1. Yep. So this is the question actually. Simple one. Yeah. So now let's do one thing. Before hopping into the approach part, let me tell you, we will be making use of the brute force. It's been ages actually. We haven't used the brute force method at all, right? So we would have went with some or the other method. It's been ages that we didn't use brute force. So let's make use of the brute force here. Yeah. Yep. Let's go with a brute force for this particular problem. Yep. So now let's consider n equals 3. This one first input actually. So I didn't explain the input output part here. So see here. So this is the input output part. So the output that we need to get here is this one according to the criteria that they've given in the question. So let's consider n equals 3. So we have been given here n equals 3. Example 1, let's consider here n equals 3, right? So here we have been given n. So this one is n, right? So n we have been given 3. Let's consider the same here. See, what is the idea here? We iterate over all the pair distances, right? All the pair distances. First thing, let me tell you here. Uh, we will be going with a brute force, right? So just remember this one, we'll be going with a brute force, right? So this is fine, I believe. Yeah. This is n. We are considering the same first example here, right? So this is fine, I believe. N equals, we have been given 3. We iterate over all the pair distances, all the pair distances, yeah, where len is equal to 1, n is equal to 1 to n minus 1 to n minus 1. Yeah, for length equals 1, we test adjacent pairs. We test adjacent pairs. One is 1 comma 2 and 2 comma 3. One is 1 comma 2 and 2 comma 3. Right. Now let's go with the two queries here. The first one is here query 1 comma 2, query 1 comma 2 and 2 comma 3. So this one we are considering. Uh, query 1 comma 2 and 2 comma 3. So this is the output actually. This part let's see here. Yep. So now interactor returns 0 here for this one. Yeah, so we test the adjacent pairs actually. For this one we iterate over all the pair distances, length equals 1 to n minus 1, right? For length equals 1, we test the adjacent pairs 1 comma 2 and 2 comma 3. For the query 1 comma 2, interactor returns 0, flashlight is off, so we will continue. So this one is 0, so we will continue, right? So for the this one, what do we call? For query 2 comma 3, the interactor returns 1, so the flashlight is on, so we have found a working pair and we will stop, right? So we'll found this one working pair and we will stop. So we will return 1 comma 2 and 2 comma 3 here, right? So this is fine. Algorithm, whatever we write here, this one brute force, basically, what we will do here, we'll systematically test the pairs by increasing the separation until some tested pair returns 1, right? So it flushes, we will be flushing the output after every query just to ensure the interactiveness, right? So this is fine. Yep. So this is the actually idea that we'll be going with. This is the idea that we'll be going with. So this is pure brute force, right? So let me do one thing. As we are completely familiar with the approach, let's discuss the this one. What do we call complexities part as well? So what will be the time complexity here? The time complexity would lead to big of n square. Yeah, the time complexity would lead to big of n square per test case. So here we may test up to every pair I comma j. We may test up to every pair I comma j once, right? So we'll be going with the nested loops over length and I to produce n into n minus 1 by 2 queries. Yeah, this is fine. So this one overall time complexity we can just consider big of n square actually. Yeah. So what will be the space complexity here? The space complexity would lead to big of 1. So why it will be big of 1 actually? We'll be making use of only few integer variables and input output buffers are used, right? So overall space complexity would lead to big of 1. The time complexity and the space complexity for the code that we'll be writing in the future would be big of n square and big of 1 respectively. Now as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. So let's start writing the code here. So first thing is, as I've said, we'll be going with the fast input and the output. So let me import here input output package. Yeah. So next let's move on with a class. So I'll just go with a class here. Mm, Let me name this one. Name the class main. You can just keep any class that's relevant to the actually question, right? So now let's make use of the solution method. Actually, let's make use of the other method and let's make use of it within the main method. Yeah. So I'll just go with the here static mm, void. So I'll just write here as well nothing but the solution. So let me go with here buffered reader as well as the print writer. Buffered reader, I'll just consider BR. So I'll just consider print writer here PW, right? Or the output. So this is fine. So let me go with throws exception, right? Throws exception. So this is fine. So within the solution method, first let's read the n, nothing but the number of batteries for this particular test case. So this one will be int n equals integer dot percent, right? So this one will be buffered reader dot read line. Yeah, buffered reader dot read line. Yep. So this is fine. Yep. Integer dot percent. So as we are making use of the this one buffered reader, we are going with the buffered reader. This one, what we call variable. So now we try pairs by increasing the length, right? Distance length from 1 to n minus 1, accordingly with what we had discussed in the approach. So let's go with the two nested loops here. One is we have to try pairs by increasing the length, nothing but the distance len from 1 to n minus 1. Other one for a fixed length, we have to test all the pairs I and I plus length with a I from 1 to n minus length. So these two things we have to know. Let's write the two for loops for this. So I'll just go with for here int length equals 1, then less than n here. Let me increment length. Yep. Now one more for loop here for I equals 1, I less than or equal to n minus length. We have discussed this one. We know I plus plus. Yep. So this is fine, man. Next, what shall we do? Within the for loop, we have to print the query I, nothing but I plus length, right? Just to test the batteries I and I plus length. So to print, I'll just go with a out dot println here. Out dot println. So this is fine. I'll just go with I plus. So let me leave space here. This one will be I plus length, right? So I plus length. This is fine. Yeah, now let's go with the out dot flush nothing, but this is important for the interactive problems, right? So we are going with the interactive problems. We have to force the output to be sent. So I'll I'll just make use of the flush here, or you can just close the output close also works here. So I'll just go with the flush. Yep. Now let's move on with the further things here. So here we have to read the interactor response, right? So the basically let's make use of the while loop that skips any blank lines that may appear in the input string, right? I'll just go with a string line here. This is fine. Next, let me go with while line equals read line not equal to null, and I'll just go with line dot trim. So this is fine. Just go with is empty. Yep, this is also fine. Then let's do one thing. While line equals trim. So this is fine. Somewhere I have missed something, man. Oh yeah. Let me give one more parenthesis here. Also here as well. Yep. So we are just picking the skipping the blanks here. Next, if the stream is closed, nothing but the evo if we considered. So then we have to exit the method, right? So I have considered the variable name, this one, what do we call? Line actually. If line equivalent to null, end of the line. So I'll just return here, this one, just return. We have to exit, right? So this is fine. Next, what we need to do, we have to pass the response. 1 means flashlight on and 0 means off here in this case, right? So I'll just go with the resulting variable res. So I'll just go with integer dot pass and somewhere I have used. So this one, let me copy the same thing here. Paste it over here. So this is fine. Instead of the buffered reader dot read line, so I'll just go with here this one. What do we call? Line dot trim. Line dot trim. So this is fine. Yep. So next what I'll do, if result equals 1, then we will return. So if we have found a working pair, then we have to finish this test case immediately, right? If result equals 1, then return. Yeah. So this is fine. Yep. If result is 0, then we have to continue testing next pair, right? So this is it for the logic, man. This is it for the logic. Let's do one thing. Let's call this solution method within the main method. Yeah. Let's do the same thing. So I'll just come out of this one entirely. Why did I click that? Yeah, this is fine. Let me paste this one. Sorry, just give me a second here. So I'll just come here. Let me paste the main method. So this is purely related to the input output method. We have completed the logic here itself. I mean, we have written the logic here itself. Sorry. The logic is done here. Main logic, yeah. So we are just calling the solution method along with the buffer reader and the print writer. This one, buffer reader and the print writer variables actually we are in the output here, right? So this is basically we have written buffer data print writer along with the pass, and so we have to read the number of test cases as well, right? So along with it, this one we are just calling the main method where we have solved actual the solution method within the main method, and we are just going with a flush as it is an interactive problem. You can just go with a flush or this one close actually, right? So this is it for the code actually. So before checking the code with a different this one inputs or the examples, I just want to copy paste the signature starter template. Just give me a second here. So I'll just come here. Let me paste this one over here, right? So I'll just come here. So let me copy and paste it over here, man. Yeah. What happened here? Cannot find the symbol. Why we cannot find the symbol here? Buffered reader R has to be capital. So yeah, we are getting the output 1, 2, 2, 3, 1, 2, 2, 3, 3, 4, right? 1, 2, 2, 3, 1, 2, 2, 3. This one. 1, 2, 2, 3, 3, 4. So this is also one of the valid outputs actually. 1, 2, 2, 3, 3, 4. This is also one of the valid outputs. So we have got here 1, 2, 2, 3, 1, 2, 1, 3, 1, 4. And we have got here 1, 2, 2, 3, 1, 2, 2, 3, 3, 4. Right? So here, 1 second. But because your solution will continue to read from the close stream. So this is fine. Yeah, this can have the multiple outputs actually. It doesn't matter. So this is also correct, I believe. For whatever the code, I believe whatever we have written brute force method, this has to work accordingly with the question, man. Yeah. So I hope this is the correct output. Whatever the output that we are getting, this is the correct output actually. Let's check the same. Let me copy this one entirely. Just come to the question, the submit button here. So, yep. Let me paste it over here and hit the submit button. I hope this works for all the test cases, man. Let's see. In my opinion, whatever the code that we have written has to work actually, accordingly with the criteria what they have given in the question. Yeah. So let's check. Let's wait for some time for running on test two. Yeah, this works actually. It is not showing here actually. So yeah, this is showing accepted here, right? So this is still in running on test one. Actually, let me reload this one. Yeah, now you can clearly see here the verdict that we got here is accepted, right? So let me click on this one. Yeah. So here we have went with a pure this one brute force to solve this particular problem, right? So the problem is completely based on the graph matching actually here. So we have went with pure brute force to solve this particular problems after a long time. Yep. So this is fine, man. Yep. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.